Hi thinkers, welcome to the object-oriented design course on Thinkings Academy. In this video, we are going to start with another creational pattern, which is a design pattern, which is the builder pattern, right? So I'm actually going to teach you with the help of example and a very important UML diagram of how this builder pattern works and what are the use cases, right? So let's start with the tutorial. The first thing that we need to understand is when do we need a builder pattern, right? So first question you need to ask yourself before applying the builder pattern. The first thing is that if you are creating an object, how much that object is complex or not, right? So obviously this builder pattern is a creational pattern. So creational pattern deals with the creation of objects. So you need to ask yourself whether the object you are trying to create is a complex object or not, right? Then only this pattern will be useful. So let's see an example of what exactly is a complex object, right? So let's say you have an object which has some properties. Now you need to make sure that when you initialize that object, you have to initialize those properties with some values also. So you can do that by using constructors of that particular object. But you will see in real life that there are some objects which are complex in nature. They have so many properties and behavior that it becomes very difficult for us to actually pass all the parameters through the constructors so that we can construct a particular object, right? So here you can take an example of a car object, which we are going to discuss in this whole tutorial. So we have a car object. Let's say it has some properties like design, seats, then we have an engine, and there are some components inside of the car. So car as a whole object is a very complex object because it will have a lot of properties. It will be very difficult for a programmer and even a client to understand how to give so many parameters to the constructor, right? So how do we know that object is a complex object? So if we want to initialize a object with a constructor and the constructor requires a lot of parameters, and when you have an object which consists of more sub objects, like you can see here we have a car and we have sub objects like engine, windows, and there will be so many components, right? So this indeed is a very complex object. You will see a lot of these types of complex objects to create in programming world also. So this actually is a very overwhelming task that you need to create constructors with different parameters, use constructor overloading. You will end up creating tens and hundreds of constructors, and it becomes very difficult for a programmer and even a tester to really understand what are these constructors doing up there, right? So it becomes essential that we have a design pattern that resolves this problem so that we don't need to supply a lot of parameters and make our code more readable and make our code loosely coupled also, right? And it should be also aligned with some of the solid principles, right? So let's start with the example now. So here the first thing we are going to discuss is this UML diagram. This is a very important UML diagram, and you will be asked this diagram in coding interviews also. Whenever you are asked what is a builder pattern, this diagram is very helpful, right? You can take as many examples and you can draw from using this only UML diagram, right? So let's start with the first component of the diagram, which is this red component, and this is actually the product, right? So product is actually an object. So what builder pattern does is it builds a particular object and more specifically complex objects, right? So what the builder pattern does is, builder pattern says that if you want to construct a particular object which is complex in nature, what you should do is you should create a separate builder class and give the responsibility of constructing that object to that class, right? So here you can see we have a product. The product is the object that we want to create and supply, right? So we want a product which is an object, a complex object. So now you can see here we have a concrete builder class, right? Concrete classes are those classes which has all the implementation defined, right? So interface is not a concrete class, but these are the concrete classes which has this build function and get product function, right? So what this actually we are doing is we are taking the responsibility of constructing the whole class from the product to the concrete builder class, right? So let's say we have a product and we want to actually build it using some parameters. We want to set some parameters. We are going to use the concrete builder class, which will help us, right? So we have taken the responsibility of setting and the details and everything about this product, and we have given that responsibility to this concrete builder, right? Now you can see that this concrete builder actually implements a builder, right? So builder is an interface here, and this is a build function that it is overriding. So you can see that the concrete builder is actually overriding this build function, right? So you can see this is the build function here. The reason is that we might have more than one builders, right? So this product might need building the object in multiple ways. So let's take an example of car, right? A car can have multiple models, right? For example, let's say there is an automobile company and it produces some cars. So cars can have different models, right? So for each model, we will create a different concrete builder class, right? For example, you can see here I've written model X. So let's say there is a company, automobile company, and it produces a car, as a product. So what we do is we create a class model X builder, right? And when we will create the concrete this class model X builder, we will use this class and we will just set the product and we will return it at the final stage, right? So we need to build the product using this concrete builder. So since we will need multiple models, so we have model X builder, we will also need model Y builder and model Z builder, right? So there will be different models of the car. For that reason, I am actually taking an interface. So from this interface, I can actually implement more than one concrete builder. And to all the builders, I will just supply the product and I will be able to build it according to my own needs, right? So these concrete builders will provide their own implementation of the build function, right? So in that case only, we will be able to build the products, right? So let's say this model X has a certain design, it has some seats, but let's say this model X car does not have roof, right? It does not have roof. So what I'm going to do is I'm going to specify in the build function, we will create a separate function for that and we will specify that this car does not have a roof, right? Similarly, we can create model Y with different implementation. That's the reason why we are using an interface and we are overriding the build functions, right? Now the final part is this director class. Now this director class has the builder and a construct function, right? So this director is actually used to direct the builder on how should the object construction takes place, right? For let's say we have a car, right? So there is a proper step-by-step construction of a car. For example, first we need to design the car. Then we need to put the components of the car, right? Assembling the components. Then we need to paint the car, right? So there are different components. So we need to do that in a sequential order, right? We don't want to first paint the components and then put them together, right? We don't want to do that. We want to have a certain order of construction. So we use a director class for that. The director class will actually guide the building of the objects, right? How the objects will be built and what are the construction steps that it should take, right? Now this is just the UML diagram for understanding the pattern, which is the builder pattern, which just says that give the responsibility of constructing a particular object to some concrete builder class, which actually is implementing the builder interface, and the building procedure is guided by the director, right? So that's an important concept. Now let's move on to our example. Now you can see that let's take a scenario of the same example car. So let's say there is a customer who comes to an automobile company and he says that I want a car of model X, right? So when he orders that car, you can see I have in green color, I have created an object. You can see I am using car builder model X, right? So this is our car builder interface. So I can implement any number of models using this interface. So I've created a reference to this car builder, which is model X, you can see here. And I'm creating a new model X builder, right? So this is our model X builder. And remember that we can create objects of only the concrete classes, right? We cannot create objects of interfaces. So now you can see I'm using this interface and I'm creating an object of this class, right? So I can simply call this build function using this interface reference model X. Now, since now we have the model, right? We know that this is our model. The step is that we need to build the model, right? Which means that we want to actually, before getting the product, we actually need to build the product or construct the product, right? So for construction, what I do is I hire a mechanical engineer, right? So we have a mechanical engineer class, and to the mechanical engineer, I will give this model X, right? I will give this reference to the mechanical engineer. So mechanical engineer here is acting as a director, and he is responsible for making this model X, right? So what he will do is he will create model X, and we have a get car function. So if I use this engineer.getCar function, it will be able to return me the car, which is the model X car, right? So let's see how this will be done. So first we need to see the director class, which is mechanical engineer, and you can see it is here, right? So this mechanical engineer is taking this model X object, which is here. So we need to pass this object to the constructor and we will capture it here, which is now the builder. So what I'm going to do is I'm going to create a get car function here, right? Which will return the get car function of the builder, right? So you can see this dot car builder dot get car is going to call the get car function in this, right? So you can see that first we need to define the model X builder. So model X builder, instead of having just build, has a build design, build seats, build engine function. It also has a get car function. So instead of get product, I'm using get car function. So since I created a object of model X builder, right, which is model X, and I'm passing it to the constructor, so I can use this dot car builder. So car builder is model X, and I'm invoking the get car function, which is here, right? So whenever I will call this get car function, which I'm doing at this step here, it will be able to return me the car, right? The whole constructed car. But we know that before returning the car, we need to construct the car with the appropriate design, number of seats, and the appropriate engine, right? So the task now, the second task is to actually we can say the first task is to actually construct this car, and then only we will be able to return, right? Now you can see in this car object we have properties like design, seats, and we have a sub object which is engine. And you can see that this car implements the car structure which is basically an interface which has these methods: set design, set seats, sets engine. I can actually use this function to set the values of these objects and properties. So that's why I'm implementing this car structure, to keep the logic in a separate fashion, so I can actually make changes here if I want to, right? So now what I'm going to do here is, you can see we have a construct function here, right, which is this part. Now to the construct function, I'm going to say this dot car builder dot build design, right? So the first step is to build the design. So I'm going to say car builder dot build design. So you can see here that this model X builder has a build design function here, right? Now this build design function, which you can see on the top here, I've written here that this build design function is going to actually take car object. So we will create a car object just like the product. So our product is car, and we will create an object of this car, and we will provide it in the concrete builder class, right? So I can create a car new object using car equals to new car, and I will supply it here. Then I will use that object to call the set design function X, right? So we will set the design as X. So this function will actually set the design property of the car, right? So design will now be equal to X, right? Similarly, I can call the build seats function, and the build seats function will actually set the seats of the car object, right? So you can see here clearly how the call of build design, build seats, and build engine function is going to invoke the functions which are there in our concrete builder, right? So model X is a concrete builder, and you can see how step by step I am actually building the design, the seats, and engine. And these functions, you can see, are actually setting the values of the object or the product or the car that we have in our case, right? So it is very important to understand that we have actually separated the logic of constructing this object and passed it to this concrete builder, which in our case is model X, right? And here you can see using this construct function as a client also, it becomes very readable for me that okay, first we are building design, then we are building seats, and then we are building engines. And you can see there is no need of creating constructors in this car class. So our product class does not have any constructors at all. So this is actually, we are passing to the build object, right, which is the concrete builder, and we just call the concrete builder, right? We call all the functions of build inside the concrete builder, which will actually is responsible for setting the values of the object, right, or the product. Now what will happen is, now since we have built the product car with the design and with the number of seats, now we can actually use the get car function or the get product function, right? So we can use the get car function here, and this function will be able to return me the product, which is the car, right? So it will be able to fetch the car. So you can see that this engineer.getCar function will actually give me a new car object, right? So it will get me a new car object, and this car will have the design as X because we have used car.setDesign, and it will have 2 seats, right? Similarly, we can apply this concept to many such examples, and this is the very important thing, right? Now let's understand a very important aspect. It might seem to you that this model here, this UML diagram that we have drawn, it looks similar to the abstract factory pattern, and it's true because you can see that this is an abstract builder. So you can think of this builder as an abstract factory, and this is actually the factory classes that we have studied, and this is the product which we want, right? So factory classes were used to actually return and was responsible for creation of objects. But in the abstract factory pattern, we were not having the responsibility of building the object, right? So factory classes had only the responsibility for returning the object of any particular class, but it does not have the responsibility of building that object using the set design and setters and getters, right? So it is important that builder pattern is similar. It looks similar to the abstract factory pattern, but the only difference is that it actually uses the build operations also, right? So it builds the object also. All right, so now we are going to take a look at the code here, which I have written here. So I've already shown the whole implementation and explanation of this code. So here you can see I've created a car structure which has these 3 methods, which are abstract methods: set design, set seats, and set engine. And here I have the car object. Now you can see this object has 3 variables: the design, seats, and engine. This is similar to what we have drawn on the whiteboard, so I'm just implementing that only. And here you can see I have a setter. I have 3 setters here, right, which will set the design of this class and seats of this class and engine of this class, right? Now we will have an interface which is the builder, which is the car builder, and this interface has 3 methods which is used to build the whole object, right? Now you will see how we can use this car object, and you will see that this car object is actually immutable in nature. So I will not be able to use the set design, set seat, and set engine functions. I will not be able to access these functions when I will actually return this car builder object using this function, which is the get car function. So it is an important concept, so pay attention to that. So now we have a model X builder, which is actually the concrete builder, and we have made this private car object. So this is a private object, and this actually ensures that we have this object only available inside of this model X builder, and we will not be able to access this object out of this class. So we are actually trying to make this object immutable, right? So now you can see I have a model X builder, and this will actually build the car, and it will use a new operator to build a car. So we have now supplied the product to our builder. Now we are going to build the product, which is using the build design. We will set the design to X, then seats to 2, and let's say this has an engine of engine X, right? Then we can use simply this get car function, and we can just return the car object. Now here we have the director, which is the mechanical engineer, which I've already shown. Now here you can see we have a private car builder, right? So car builder, which is our interface, is also private in nature, which ensures more immutability. So if immutability is there, I won't be able to change the things which are there inside of the implementation of car builder, right? So the whole process of using builder pattern is to introduce immutability, right? So we have a constructor here. We are passing the car builder object here, which you can see here in the main function. I have created a car builder of model X builder. So I've created an object of model X builder, and I've passed this to the director, which is our engineer. So I've passed the model X to this. So you can see we have this mechanical engineer here, and car builder is actually now model X builder, right? And here I have the get car function, which we have already seen that is a function that will return the car, right? The object of car. So this dot car builder dot get car is actually going to invoke this function, which will return the object, the product, which is car in our case, right? Now we are going to use the engineer object to call the construct car, because before getting the car we first need to construct the car. This will invoke these three functions. Now it's you can see I have the build design, build seats, and build engine function. These three functions are going to build the object, which is our model X builder and model X in our case, right? So it is going to build model X with design X, seats 2, and engine as engine X, right? Now here you can see I'm actually using a car reference, and I'm getting the object using the engineer object, right? So get car function will give me the get car of the car builder. So I will get the object, which is this dot car, right? So I can get the product from here. So this is what we have studied in the builder pattern. We have the car structure, we have the product here. So this is actually our product. So I'm going to write here in the comments that this is our product, and I will give the link to this whole program on our website thinkxacademy.com. So you will be able to see that yourself, and you will be able to understand it more clearly. So here car builder is actually the builder. Model X builder is the concrete class. So I'm going to write here that it is a concrete builder. And here we have the mechanical engineer, which is our director, right? So I'm just drawing an analogy between this example and the UML diagram. And here we have the class builder, and here we are creating this. So here you can see I have this car object engineer.getCar. So let's try to print this out. Let's see what this object is. So I'm going to just save this, and I will run it, right? So here you can see that if I go to console from here, you can see that builder constructed. So builder, the object is actually belongs to the package. So the package name was thinkxacademy.com, and here you can see clearly that we have a car object and we have a reference to that, right? So this is our object. Now we need to study immutability, right? So let's see what is the design of this, right? So I can just use design property car.design to see what is the design of this car, right? So if I will run this again here, and here you can see now the design is actually X, right? Similarly, if I want to see what is the engine used, I can do that. I will again have to run this. So I will again run this, and you will be able to see that the engine is engine X, right? So we have these properties of the car. Now let's try to change the property, right? So I have the car object. So I can use this object to call the set design, which is here, right? So you can see that I have the car implementation here. So we have the object of car. So let's see whether we are able to call the set design, set seats function. Then only we will be able to ensure the immutability concept, right? So am I able to set the design of this car again, right? So let's say I want to set it to Y. Right now you can see that it gives an error here which says operator plus is undefined for the argument, which means that I do not have the ability to change the design of this car after I've built it, right? You can see I've built it using engineer.getCar. So this is actually the object I'm getting, and I do not have access to the set design function, which is the setter. So since I do not have the ability to change or set the properties of this car object, I'm going to say that this actually is an immutable object car, right? And we are ensuring that this is basically a immutable object by using private private in two places. So private keyword will be used in the car builder. So our concrete builder or our builder, right, which is the interface, needs to be private. And the second thing is the object, the product that we are supplying to the builder class, which is the concrete builder, it should also be private, right? So once we ensure these two things, we are good to go, right? Just make sure that you make the car builder as private, the director, here you can see car builder is private, and then you need to make sure that the car or the product supplied to the concrete builder is also private, and then you can ensure the mutability, and you will be able to check that if you write any function here, if you try to call any setters from using this object car, you won't be able to do that, right? So basically that's all for this tutorial. Thanks for watching.